QCM series all-in-one machine is a combination of our AP main tower and auxiliary tower. Our AP heating and mixing are carried out in the main tower, while raw material screening and storing are carried out in the auxiliary tower. The cold bin loading area is enclosed on 3 sides and installed with a dust hood to collect the dust generated there in an organized way. The feeding belt conveyor feeds materials via frequency conversion stepless speed regulation, and a dust hood is installed at each discharge opening and belt connection to gather the dust generated there in an organized manner. The drum is submerged arc welded with G20 boiler steel plates. The mixing ring is a number 45 steel forging part, and the supporting roller a 40 CR forging part. The raw material drying system is a bionic computer-assisted hot air furnace designed for lifting purpose, which, by combining 3 keys together, namely feeding speed, exhaust temperature, and chute feeding temperature, and by integrating with a PLC temperature module, can intelligently control burner fire to achieve the purpose of automatic temperature control. The feed chute and the discharge chute are equipped with wear-resistant composite steel plates. After the hoist is connected with wear-resistant alloy double plates, the drive is more smooth and reliable. Driven by dual vibrating motors, the vibrating screen is safe, reliable, durable, and maintenance-free. With a large capacity hot storage bin, the dispensing amount and material spillage can be more accurately controlled. Supplementary materials are measured by means of large-small door superimposition, which can increase measurement accuracy. After rigorous pre-treatment, wrap is loaded into the RAP cold bin, which can be laid out in a ground, half-ground, or full-ground manner according to site conditions. The feeding belt conveyor is fed by frequency control, and each of them is provided with an arch braking device. The hoist is made up of rake-type lifting plates, and the feeding inlet is a large angle chute that can quickly send our AP into the drum. The reclaimer is specially designed to achieve the combustion effect, and its flame is short and thick so that the reclaimed material will not touch the open fire and prevent the wrap material from aging again. The flame in the hot air furnace is converted into 600 degrees Celsius hot air flow to enter the drying drum. Our AP pellets are in full contact with hot airflow to achieve wrap heat exchange and reach the required temperature. The reclaiming drum is composed of chain structure blades that are densely and evenly distributed, and the RAP forms a wide and thin material curtain inside the drying drum. Heat is fully exchanged between our AP and hot airflow. Flexible bionic technology and the flexible lifting curtain allow the drum to be self-cleaned to effectively prevent sticking. The hardness of the chain is up to HRC 50 after heat treatment. The inert gas heat cycling technology introduces the inert gas that produces very low oxygen content after heat transfer into the drying system through a special fan, so that the RAP can exchange heat in an oxygen-efficient state to reduce heat-caused aging. After heating, the exhaust gas of our AP will contain a large amount of refined oil, which is introduced by a special fan into the raw material drying drum, where it is carbonized after burning, and then discharged after being dust down by a main bag filter. The temporary RAP storage bin adopts the form of weighing to display the amount of material stored, and the hatch is dual-cylinder interlocked for opening and closing. The measurement is strictly controlled in a descending order of closing the hatch doors. Both the temporary RAP storage bin and the measuring bin are internally lined with stainless steel plates and provided with a heat transfer oil cycle heating system to effectively prevent blockage. The measuring bin is driven by 4 cylinders for measurement. The pulverized materials are pumped into the powder tank by the tanker truck and then sent to the powder metering hopper via a screw conveyor in a frequency conversion control manner. All measuring systems have 3-point pushdown transducers, and the asphalt heat transfer oil is heated to the required temperature and conveyed to the asphalt measuring unit by a frequency control screw pump. By the use of patented technology, the addition of reclaimed additives can reach 1/1000 to 3/1000. The main mixing unit is set on one side of the reclaiming unit to vertically drop reclaimed materials, which has shortened the feeding time, and flexibly driven to realize synchronous drive at the high speed end. The finished material after mixing is conveyed to the storage bin through a trolley. A dust hood is installed in the storage bin to uniformly collect the generated asphalt fumes. The fumes generated during unloading are collected by the dust hood. The driveway is made into an enclosed corridor and arranged with automatic fast-rolling doors at the front and rear. The environmental protection system removes the dust in a size of less than 0.075 millimeters from the main bag filter. Then, the dust is pumped into the asphalt-containing fume duct through a roots blower, and the atomized and wrapped dust enters a fume purification dust remover. After backblowing, the dust is pumped into the main bag filter through the roots blower and then discharged to achieve the fume treatment effect. The dust collected by each cold material system is collected by the bag filter and spirally sent to the cold raw material conveying belt before entering the drying system. The main bag filter is an incremental configuration that can fully absorb the fume generated during recycling. The filter is placed above the raw material drying system to shorten the fume duct, cut temperature loss, and save energy and floor space. In the oil tank area, the cool air is gathered for circulation. This QCM series all-in-one machine is a dual machine and dual mode system intended to guarantee the stable and reliable operation of each subsystem.